said greater than, I get to shade just the side of this this distribution that's greater than the 1.897. Okay, so now I need to find the probability that I get a sample this extreme or even more extreme from the mean. So to do that, I get my p-value, and to get my p-value, I'm going to do a normal CDF. From 1.897 to a positive infinity. Anybody think they can get that one for me? .0285? Got it. Okay. Now, do I have statistical significance? Yes. If P is less than alpha, oops, I didn't make an alpha there. So 0.03 is less than 0.05. We have statistical significance. We can reject or refute, however you want to call it, our null hypothesis. So we have evidence that the null hypothesis is wrong. We have evidence that our mean is actually greater than 100 and not equal to 100. Okay? Now what would happen if my alpha, if I had set my alpha to 0.01? We would not have statistical significance. Okay. So this is why you're not supposed to set your alpha after you've run your test. It's cheating, because I can get different results from the exact same sample, from the exact same everything, if I just change my alpha. So you have to set your alpha before you do your test. And the ways that you set your alpha, it's not a guessing game, but it is, we'll learn a little bit about how you would set alpha. Alpha tells you how often you're going to incorrectly make a conclusion about with your significance test. And if your alpha is 5%, your conclusion of your significance test is going to be incorrect 5% of the time. If your alpha is 10%, you're going to report an incorrect conclusion 10% of the time. So you like to set your alpha low so that you don't give incorrect results very often. But then there's a trade-off, and we'll talk about the trade-offs. It's type 1, type 2 errors.